All right, everybody. Before we get started, I want to remind everybody, if you want to get CME, the information is on this slide, so I'll leave it for another few moments before we start the session. All right. Well, this is it's a pleasure to be here for the State of the Night ADRC annual address. So I know almost everybody, but I'm Dave Holtzman, Professor of Neurology at WashU and current PI of the Night ADRC NIH grant. So I have a lot to cover, so I'll just get going. Oops, there's my disclosure statements are here. So as many of you know, this really has been an unprecedented era in Alzheimer's disease and related disorders, both research and finally now clinical care. So the first disease-modifying therapies for Alzheimer's disease were approved about almost 3 years ago with lecanemab and donanemab, and we certainly anticipate many other therapies coming forward in the next several years. Blood-based biomarkers have advanced where now they're being utilized, and I'm sure they will be utilized much, much more, literally by the month. And I think the Night ADRC was instrumental in ushering in this new era. First, with the first in vivo demonstration of preclinical Alzheimer's disease using amyloid PET scans in individual research participants followed here was published in Neurology in 2006. We were the first to show that preclinical Alzheimer's disease is determined by CSF assays or amyloid PET predicts cognitive decline, both through many different clinical research studies, ACS, DIAN, DIAN-TU. The first ever prevention trial was launched in 2012 by the DIAN-TU, and the first ever trial with combination therapy was launched in the DIAN-TU in 2022. And then Randy Bateman and I co-founded C2N Diagnostics 19 years ago, and this has developed one of the sets of blood tests that are now available clinically. So what are the central themes of the Night ADRC and its affiliated program projects? I think this really began back with Leonard Berg, John Morris, and others, and we really stuck to this throughout the course of the clinical research that's been going on here. Namely, when in the lifespan does AD pathology, including accumulation of A-beta, tau, other changes such as inflammation, when does it begin and how does it change over time? What are the factors that increase risk for developing pathological Alzheimer's disease? Things like systemic and intestinal inflammatory changes, the microbiome, physical activity, cerebrovascular disease, social determinants of health and reported race, sleep and circadian rhythm changes. All these things we have evidence for that they can modify the disease. What are factors that influence the transition from asymptomatic to symptomatic AD? Those are still primary questions that we're all asking using different techniques. We show this every time, but just to remind everybody that while the Night Alzheimer's Disease Research Center grant is what's listed here in blue, which has several developmental projects as well as components of different cores, some specifically in the Night ADRC and some that are shared between other projects, you see that there's a minimum of at least 3 other major large program project type grants that support the clinical research here, including the Healthy Aging and Senile Dementia grant we'll talk more about in a moment, the Adult Children's Study, and then also the Dominantly Inherited Alzheimer Network. And really, the Memory and Aging Project is the home for the clinical participants that are involved in all the clinical research that are part of these studies. So as you probably all are aware, the Night ADRC is incredibly interdisciplinary. We have faculty from 16 departments. That includes at the Danforth campus in the Department of Psychology and Brain Sciences and the Brown School of Social Work and Institute of Public Health, the Olin Business School with Mahendra Gupta that's helped to improve recruitment into AD clinical trials using a web-based tool that incorporates plasma biomarkers in collaboration with Suzanne Schindler. And then in the Department of Political Science, Matt Gobble has worked on conducting national surveys to understand motivation to participate in AD research. So what's listed here are the Knight ADRC grant, but also the other major grants that are directly linked with the Knight ADRC. But then there's a host of other NIH-funded grants that are also in some way or other that the Knight ADRC contributes to, or that we are supporting in some way or other grants. So for example, you can see the ABCDS, this is a study in Down syndrome that Bo Ansis is leading a site here on. There's many other affiliated grants. So this is, the Knight ADRC can kind of be seen as a hub really for AD/RD research at Washington University. So our governance structure is that I'm currently the director of the Knight ADRC, Krista Mulder is the executive director. We have an external advisory committee meeting that's now started re-meeting again now that the grant is renewed. We just had a meeting about a month ago. It went very well, which is great. We have an executive committee that meets, if we're in town, every Wednesday morning from 7 to 8. That includes myself, John Morris, Krista Mulder, Randy Bateman, Carlos Grushaga, Celeste Karch, and Eric Music. We report to a leadership committee of the Knight ADRC where we meet every other month and go over different protocols, different projects that are being proposed. And then we also have a biospecimens committee that reports to the leadership committee, which meets today at 1:30. So in terms of all of the ADRCs are required for succession planning, just a very brief summary where we are now. I became the PI and director of the Knight ADRC July 1st, 2023. John Morris, the prior director, remains leader of the ADRC's clinical core. Justin Long is now the clinical core associate leader. John Morris remains the PI of the two program projects, Healthy Aging, Senile Dementia, and Adult Children Study. Again, I'll speak more about those in a minute. Justin Mazurski joins Andrea Denny as co-leader of the OR core. And then Cyril Pradier joins Carlos Grushaga as co-leader of the Genetics and High Throughput Omics core. So we've been, as usual, incredibly busy. In terms of the current grant, we submitted the current funding cycle, which is now that it's been renewed, is May 1st to April 30th, 2030. So that's great. We're just ending the first year of the current cycle. The grant was resubmitted in June of 2024. We had to do a variety of things due to the current administration, which is trying to kill science, but we were able to get through this, and that it did get funded in July of 2025. The Diane observational renewal is in progress. It's been quite a journey. I won't go through all the details, but even though this is one of the arguably one of the most important clinical research studies in the world, studying early onset or dominantly inherited Alzheimer's disease, we've struggled. The renewal submission went in September 23. It wasn't supported, so we resubmitted it. It was re-reviewed September 2024, wasn't renewed. And then this time, though, in the renewal submission that went in the fall of 2025, it did receive a very good score of 22, which is incredibly competitive. I think everybody's optimistic now that this will be funded. We're just waiting to hear with all the delays in the government, again, due to our administration, on the final act of funding for this. There are many cores as part of this Diane observational grant, but there's only one single scientific project which is working on the A beta and tau link and novel mechanisms of disease progression. The dominantly inherited Alzheimer's disease trial unit, that's part of that is the amyloid removal trial. Participants, because that's currently not funded, participants in this were enrolled in the Diane observational study so that they could continue to be followed and receive treatment so far that are now on lecanemab after switching off gantenerumab. So in regard to the grants that I mentioned before, the HASD adult children study, there were two different grants, one studying adult studying people from 45 to 75 when they enroll, and then the HSD grant is people generally of average age about 75. These, after Dr. Morris spoke to Dr. John Shaw at the National Institute of Aging, it was decided to combine these grants with a new submission instead of just having two separate grants. The idea of this quote unquote super PO1 was endorsed by the External Advisory Committee for these grants. Dr. Morris and Suzanne Schindler as multi-PI leaders of this grant. It was submitted a year ago. And the submission score, again, for many of you are familiar with NIH scoring, but it goes 10 is the best, 90 is the worst, 50 is like average, received a 31, which is a very good score. The program officer, Dr. Shaw, is optimistic, but is recommending resubmitting the grant if in the fall, although it still may be funded before that time. So we're cautiously optimistic, but we'll see. If it has to be resubmitted, that will be done in the fall. So the combined new large grant as proposed includes several cores that are listed here. And then in addition to that, there are 4 projects, because I'll talk about this more in a minute. The City Partners Brain Health Study, or COMPASS, where this is led by Dr. Morris. This is looking at plasma biomarkers of Alzheimer's disease in a population representative cohort. Suzanne Schindler's project is examination of diagnostic tests and treatments in a clinical cohort. Carlos Cruchaga's project is detailing multi-tissue molecular characterization of clinical biomarker onset and rate of progression. And then Tammy Benzinger's project is identifying factors affecting amyloid tau and symptom onset. So this will be very exciting once it gets funded, and we look forward to hearing all the cool things that come from this. So we've been very fortunate in regard to philanthropy for the Knight ADRC and its affiliated program projects. There are 2 endowments to the Knight ADRC that support general operations and special initiatives. Especially want to call out immediately Joanne Knight and her family for providing this endowment originally. It's been incredibly helpful for everything that we do. The expendable funds that we have from philanthropy have allowed us to do things like improve infrastructure, capacity, and support. As you all know, that ahead of NIH funding, you often can't completely complete everything you're doing, especially a large grant, without additional funding beyond the NIH grants. Some of the philanthropic funds have supported new research projects, including developmental projects, and some of the REC scholars. We actually have more REC scholars than is just in the grant because of the philanthropic funds. We've also established the HDE core with philanthropic funds, and this COMPASS project I'll mention more in a moment. And then we are using around $900,000 a year to support ADRC renewal initiatives that are not covered by the capped NIH funds. Again, as listed, as I just mentioned, some of the things that we're funding with this. Despite this, we still haven't had to do belt tightening because of the issues with NIH funding that, as I just went through with you, is affecting some of the largest grants that we have. So there's been no reduction in current staff, except not replacing staff who retire or take another position. We've been temporarily halting reimbursement of travel expenses for out-of-town participants. We've been limiting the assays of fluid biomarkers until we have more funding to be able to do this, and also halted the enrollment of new participants in our studies for not right now. So we hope this will stop very soon, that we have to do these things, but reality is that's where we are. In terms of NIH funding, not all, but much of the funding for AD/ADRD comes from the National Institute of Aging. At a recent spring meeting that happened in May, Ken Santora, who's the NIA acting deputy director, confirmed at the spring ADRC directors meeting that pay lines will not be set for fiscal year 2026. This is true of all the NIH. They no longer theoretically are using pay lines. So the 4 factors determining which grants are awarded are not that necessarily that different than before. They include things like, does the PI have early stage investigator status? Does the grant fit the programmatic priorities and balance of what the goals are of that agency? What's the priority score? And what's the availability of funds? So I think going forward, there are going to be, and there are already, you could potentially respond to a published highlighted topic. This will be taken into consideration during funding decisions. And I know Krista just mentioned to me, and we'll go over this more to the community, that, for example, a recent highlighted topic is studies regarding neuroinflammation related to Alzheimer's disease. So that's an example of something that you can write on your grant application as a highlighted topic. And there are other ones as well. That's just one. So you probably all have been hearing the last month, if you haven't, that the Office of Management and Budget of the government, so this is not the NIH, this is the office that controls payment of federal funds in general that go to different things in the United States. So this office, which again is controlled by the current administration, proposed federal grant rules, which would give much more control over federal grants to political leaders, unfortunately, not scientists. This could change how grants are awarded, managed, and even ended. Now, these proposed changes haven't gone into effect, which is important because there's a period now where anybody, any of us, universities, foundations, we can all respond to the proposed changes. And this is the website that you can respond to these changes up until July 13th. So I encourage everybody to respond to some of the things that are listed here that are included in potential changes, such as peer review recommendations are no longer binding. Political appointees can override scientific community's judgment without cause. Active grants can be terminated at any time for any reason. Applicants can be denied based on their affiliation with civil rights, environmental, or public health advocacy or an organization. So essentially, a completely regressive set of rules that would potentially has a chance to destroy even more what's going on. Now, this probably would change, I'm sure, with the new administration, but this is still a fact. And so if you do comment on it, the more people that comment, they still need to take the comments into consideration as to what the new rules may or may not be. All right, so in terms of the clinical research that's going on in all of these grants, the Memory and Aging Project oversees the coordination of seeing and evaluating research participants. And Dr. Morris is the director of the Memory and Aging Project, and Justin Long is the associate leader. Nicole Elmore is the associate director and oversees many aspects of the Memory and Aging Project, including the nurse coordinators, social workers, project managers, and then the advanced practice clinicians. In addition to all of that, all of the staff, there's also faculty, physician, clinicians that also see our research participants, and they're all listed here. And then there's a cognitive assessment unit that Jason Hasenstab oversees, and you can see the list of all of the clinical research coordinators. So you can see how large this operation is and how comprehensive it is in order to actually follow our participants and get everything right in terms of being able to do really accurate and high-level research longitudinally. So into last year, the MAP participant characteristics that we see, we were actively still saw 955 individuals in the Memory and Aging Project. How they are sort of budgetarily paid for is listed below. The HSD ADRC grants we're covering 619 of the participants are in evaluations and follow-up, and the adult children's study was responsible for seeing 336 of the people. In terms of what the participants do, everything is standardized no matter what grants pay for them, but this is how it works. You can see the age range is 40 to 97. It represents 58% women, 16% African American, which is about the percentage of African Americans in the St. Louis metropolitan region. I think it's 18%, but it's close. And you can see people come from all over the United States. And one of our participants has been here coming 39 years, which is pretty incredible. We just had the MAP participants meeting on June 6th. Unfortunately, I wasn't able to attend, but it looks like a lot of people did. There were 381 participants and their study partners. 40 night ADRC faculty and staff also attended, and you can see The speakers, Dr. Morris gave an overview of the night ADRC. Stephanie Griffin talked about a participant's experience. Justin Long talked about late, which is another, it can be an Alzheimer's mimic clinical disease. Kellen Peterson talked about biomarker results predicting the onset of dementia, and I'll highlight a study that he and Suzanne Schindler and many others were involved in later in this presentation. And then Ji-Young Han talked about the current landscape of disease-modifying treatments in our memory diagnostic center. So you can see the breakdown of all of the participants that we see that are not related to the dominantly inherited Alzheimer network. Of the 955 people, you can see their average age is in the 70s. You can see their average education level. They're highly educated. And the differences in terms of African-American percentages and ApoE4 positivity. It's a little higher than the general population for E4, probably because a number of people often get interested in this study because of potential family members that had Alzheimer's disease. So there's a lot of affiliated studies that utilize our participants and their data in order to do studies of their own. And this just gives you a feeling what some of our participants are referred to that are beyond the biomarker studies that are necessarily directly part of the NIGHT ADRC. So things like, for example, blood draws, sleep studies, microbiome studies, exercise studies, et cetera. And then there's a number of extra studies that other people also are involved in at Washington University and elsewhere, such as brain metabolism studies, a drive study, deep learning, fall studies, et cetera. So I think one of the things this highlights is that the NIGHT ADRC participants and its affiliated studies really allow many other people to do more clinical research than just is done that's funded directly by those grants. So as you probably have all heard, the participation of the participants in our studies is probably second to none. You can see the percentages of the people that are seen as part of the Memory and Aging Project. 100% gave blood. Between 85 and 90% participated in getting amyloid PET scans, tau PET scans, MRI, lumbar punctures, and autopsy if they pass away. So I'm not aware of any other study that's this the participants are that devoted to participating in research. So we should all be really thankful for what they're doing. So one of the things that the NIGHT ADRC and the program, NIGHT ADRC specifically is contributing to, although our other projects also are, is a relatively new project called SCAN, which is Standardized Centralized Alzheimer's Related Dementias Neuroimaging. This is where all of the ADRCs that are funded by the government, so I think there's more than 30, each have to contribute some number per year of people's MRI, amyloid PET, and tau PET. Krista, I think it's like 15 or something like 24. Okay. So just from the NIGHT ADRC, we contributed more than 24 of each of these. But when I actually looked at the list of different scans that were contributed by the Memory and Aging Project broadly at WashU to this scan, we were the most of any site in the country. So that's pretty amazing. And it probably is because we've been so invested in doing different neuroimaging studies over many years now. So one of the things with the new disease-modifying therapies that we've had to get involved with from the research participant perspective is that now that there are disease-modifying treatments and we see research participants that are not necessarily in our clinics here, if somebody clinically becomes impaired, and it's noted, we now have a method where we will share the information from the biomarkers in somebody who is impaired. This has been done through different mechanisms. So there's actually a grant. We share a multi-PI grant led by Sarah Hartz, returns biomarker results to people that are CDR greater than 0, so some impairment. if the participants who wish to learn, for those who want to learn them. And Dr. Morris joins the discussion when amyloid targeting therapy might be a consideration. So this is really helpful. At least everybody then has a chance, if they want to consider therapy, that they can get referred on for that. Some of the major issues, though, are the limited capacity of our own faculty outpatient practice, the Memory Diagnostics Center, to evaluate and treat all potentially ATT eligible patients. But everybody's working on this actively. So, of course, one of the main missions of the Knight ADRC is not to just generate data, but it's to share the data. So our mission as an ADRC is to foster and facilitate AD research here and at WashU and beyond. So we make not only our resources available, the data, biospecimens, and participants, but we also actively promote their use. So in the last ADRC grant cycle, we fulfilled over 5 years, 289 resource requests, and you can see how that's broken down. And this supported other grants that were funded for almost $300 million. So you can see how this is building upon itself by gathering all this information for the entire AD-RD community. So these are the kind of things in the last year that were in which samples were generated by the Knight ADRC and given to others. So 40 of the requests were data only, some were tissue, 7 were for participant requests. So this contributed to 63 publications that were reported just in 2025, plus 10 clinical trials. And so many of the resources that were shared contributed, 43 were from federally funded grants. So I think the NIH and taxpayers are getting good use of all of the resources that we're generating. So in order for any large operation like ours to really be successful, we have many partners. One is the Greater Missouri chapter of the Alzheimer's Association, who've been incredible partners since the 1980s and continue to be great partners. The African American Advisory Board, who is led by Pastor Douglas Petty and Reverend C. Jessel Strong, have been incredibly helpful when Dr. Morris started working with this and Mr. Say many years ago, and it's really blossomed into an incredible partnership. We also have the Ethics Committee, Links Incorporated, the Harvey Friedman Center for Aging, the Hope Center for Neurological Disorders, BJH Foundation, and many, many different components of Washington University have been incredibly supportive of the Knight ADRC. The Chancellor Martin, current Dean David Perlmutter, and Neurology Department Chair Jinmu Lee. We've had, over the last several years, we've had really amazing help from University Advancement and Media Relations through Pamela Henson, Will Arvin, Emily Wozniak, Kristen Chan, and Jessica Church. They've been so helpful to us in many ways. We had many incredible donors and friends, including, as I mentioned, the Knight family, Roger and Paula Riney, Daniel Brennan, David and Betty Farrell, Ruben and Barbara Morris, Donna Kono, the Poletsky family, and the Blumenfeld family. And there's even more, but it's just amazing how supportive our community has been of the Knight ADRC. So since 2000, we've had an outstanding African American Advisory Board that provides counsel on cultural sensitivity and outreach strategies and encourages participation in research by individuals who identify as African American or Black. This represents our research mission to the community. And you can see area leaders in education, diversity, the clergy, community advocacy, healthcare, and media communications are all components of our African American Advisory Board. And I listed earlier the chair, Pastor Douglas Petty, and Reverend C. Jessel Strong. So we hope to continue this in perpetuity, and it's been incredibly helpful. We just last year celebrated the 25th anniversary of the African American Advisory Board with the 20th Say lecture. The lecture was called Honoring Legacy and Accelerating Progress, and we had past lecturers, Consuelo Wilkins and Crystal Glover, present for this. And you can see all the members of the African American Advisory Board after the Say lecture last year. We also had a roundtable discussion led by Dr. Morris with panelists Joy Ballsbury and Dottie McDowell. And just upcoming this next year in October 1st, will be the 21st annual SAY lecture. Our speaker is Raina Robinson, who's from Vanderbilt. And she's very recognized as an emerging leader in proteomics and the study of Alzheimer's disease and aging. So please attend this if you can. And we'll send out more information over the coming months of the time and location. So going back to the large program project that we hope will be funded soon, one of the projects is focusing on what's called the COMPASS Community Cohort. And the reason that this project was started is that now that we have incredible blood-based biomarkers that can tell you things like whether you have amyloid in your brain or whether tau pathology is emerging and present, we'd like to correlate this with clinical cognitive measures derived from cohorts that are, so far, we've done this all in people that are generally healthy and highly educated. So the goal of the Community Partners Brain Health Study is to look at people who really live in our community, not just people who are only healthy and highly educated. So the goal of this is to recruit greater than 50% Black individuals with an educational attainment of less than 16 years, which is our average attainment in our current studies. And also have many of the comorbidities that we frequently see in people, such as hypertension, dyslipidemia, and diabetes, for example. So the idea is to meet participants where they work and live in collaboration with our community partners and the HDE core. And the participants would complete a standardized clinical cognitive assessments that we do in the ADRC and get a blood draw. And then Dr. Morris led a pilot cohort of 38 people that were recruited in 2025. 71% were Black. Mean education was only high school level. And of the 14 participants that are eligible for their second visit, thus far 6 have completed and 7 are scheduled. So we're making good progress as a pilot that we can get this to happen. And one of the things that was also piloted is a COMPASS mobile MRI pilot. And this occurred in February and March, where COMPASS participants were invited to undergo a less than 30-minute brain MRI using a mobile hyperfine MRI scanner. So this is the truck that the MRI is in. This is Dr. Morris right next to where the MRI is. So 11 participants completed the scan and reported very positive experiences. And the additional low burden biomarker collection this provides and an opportunity for community engagement, I think, is great. And hopefully, as COMPASS emerges as a project, we'll be able to do this on many of the individuals who participate. So you heard it's almost 3 years now, not quite, that we've started utilizing disease-modifying therapies in our clinic, the Memory Diagnostic Center. In the center, we see about 3,400 patients annually. There are 14 physicians, 1 physician assistant, 3 nurse practitioners. So since August of 2023, we've treated over 600 people with both either lecanemab, which became available first, almost 500 already, and 148 people on donanemab. So this is an incredible effort that started many years before this was available, and many, many people have contributed to allowing this to happen. My understanding is that we've treated more people at any one single academic center than any other place in the United States, probably in the world. Our overall incidence of amyloid-related imaging abnormalities, one of the side effects you can see is about 22%, which is very similar to what was seen in the initial clinical trials. And only less than 1% of those individuals have been symptomatic. So not trivial, but relatively safe if done following all the rules of the road. And this is a very nice graph. I think Suzanne was responsible, or if not for others, making this, where you can see this is the enrollment of patients over time that have been treated with disease-modifying therapies. So in addition to treating patients, Dr. Snyder, who leads the Knight ADRC clinical trials unit, and many of the people that work with her have been incredibly busy. They're involved, and not just the Knight ADRC clinical trials unit, but also the Diane treatment unit, which also, at least on site, recruits people into that same clinical trials area. So the Diane treatment unit primary prevention study is currently recruiting. This is led by Eric McDade. It's the first trial to target people at risk who have a genetic mutation that will almost 100% lead them to getting Alzheimer's disease at a young age. But they're being recruited before they develop significant amyloid deposition to be in a study of an anti-amyloid antibody, remternetug, which is very similar to donanemab. And this is administered subcutaneously, and it's designed to target and remove amyloid plaques at individuals at risk to develop dominantly inherited AD. There's another trial START. This is ongoing. It's not currently recruiting. It's a phase 2 therapeutic trial by ACTC and the Cognition Therapeutics. And it's using an agent that theoretically displaces toxic amyloid beta oligomers to protect synaptic function. The Diane treatment unit has other secondary prevention trials that are ongoing. It's not currently recruiting, I think, on site, but because I think it's been filled our site. It's a phase 2-3 interventional treatment studies. Again, Eric McDade is the PI of this. The sponsor is Diane TU and Washington University. The trial includes anti-amyloid and/or anti-tau approaches, sometimes together in the different arms of the trial. I think it's the first combination trial that's ever occurred so far, and we're targeting amyloid and tau in the same trial. We also have been very active in the AHEAD 3-4-5 trial. This is phase 3 secondary prevention trial sponsored by ACTC and NIH and in partnership with Eisai and Biogen. It's using lecanemab to remove amyloid, but it's being given to people that are cognitively normal that have different levels of amyloid. I think this reads out in about 2 years. Everybody's very optimistic about this being a successful trial, but we'll find out in 2 years or so. Trontier is an ongoing, not currently recruiting study, which is phase 3 trial by Roche and Genentech, which uses a brain shuttle coupled to an anti-amyloid antibody, gantenerumab, so that the antibody gets into the brain at about 10 times higher concentration through the blood-brain barrier directly. In phase 2 trials, it rapidly removes amyloid from the brain over 3 to 4 months instead of, let's say, 9 to 12 months. And so far in the phase 2 trial, the side effects of ARIA were significantly lower than occurred with peripheral administration. Traveler is also ongoing, not currently recruiting. This is also by Roche and Genentech. And it's basically recruiting individuals based on blood tests to identify those who will be eligible for future Alzheimer's treatment trials. It's not a drug study. APEX is also ongoing, not currently recruiting. It's also sponsored by the NIH ACTC group, but it's conducted by the Brigham and Women's Hospital, and it's collecting samples so that one can better understand blood biomarkers, amyloid accumulation, and other factors. Other trials is Preventron, is a phase 3 preclinical Alzheimer's disease trial by Roche and Genentech, and it's evaluating, again, this brain shuttle antibody trontinemab. I think it will start, again, this will open late 2026, so we'll be looking for individuals to recruit to this. Tremhance is a phase 2 AD treatment trial with Sanofi. It's using an oral small molecule TREM2 agonist designed to enhance microglial function. The ATP Alzheimer Tau platform trial is also evaluating Tau-directed therapies, initially a vaccine, an active immunotherapy targeting Tau in combination with donanemab. And then Voyager will launch here a phase 1 in-human gene therapy study in which they're trying to knock down using an AAV vector Tau. So that'll be exciting to do a phase 1 study here. Okay, so some of the newly funded applications that have occurred that are linked in some way or other to the ADRC or its investigators include there's the National Alzheimer Coordinating Center partnering with the Alzheimer's Association offers yearly competitive new investigator program awards. I think we're the only institution that applied where two of our investigators got awards this year. Rajan Liu and also Matt Wellhalf. So that's fantastic. And you can see all the different NIH grants which were funded over the last year that were in some way or other supported by the Knight ADRC. So 5 R01 grants, 1 large U01 grant to Carlos Cruchaga, R61, R21s, R13, and importantly, 3 K awards. So these are career development awards that are so critical in enabling people to go from in a lab, but then move to their own independent lab ultimately. So the Knight ADRC and the other NIH funded ADRCs no longer fund large like R01 level projects, but they do fund developmental projects. And we currently, of the current cycle, we have 4 projects. One is led by Gus Davis, studying the impact of alpha-synuclein co-pathology on outcomes in people with AD treated with anti-amyloid antibodies. Michael Beloy, a fantastic new independent PI, is looking at genomics and multiomics driven discovery of ApoE4 stratified risk genes. In fact, if you look him up on PubMed, yesterday, one of his papers that was just published on this topic. Aisley Cheney in radiology is using diffusion-basis spectrum imaging, or DBSI, as a biomarker for neuroinflammation in Alzheimer's disease that is validated by other imaging methods. And Abi Iyer is defining the role of microglial tau pathology in tauopathies. So really exciting new projects that our advisory committee all was very impressed at a month ago. So one of the missions of the Knight ADRC is to support outstanding new investigators. And one way we do this is to give yearly awards. So the Richard and Mildred Piletsky awardees this year that just received these awards are Fazana Mirfakar, working in the Karch lab, and Daniel Western in the Cruchaga lab. I will highlight one of the papers from each of them in a moment. And then Peter Millar, an instructor in the ANSYS lab, was also the winner of the Blumenfeld awardee. So congrats to these folks. They've done a great job. It was incredibly competitive. We have so many good young people who are at ADRC, or linked with the ADRC. So one of the great programs that's part of the Knight ADRC is a program to fund research and education course scholars. So these are individuals who are moving up in their career, usually end of postdoc, instructor level, junior faculty, sometimes assistant professors that are learning, in addition to their own research, are learning more about AD/RD related research in general through this program. You can see there's incredible people: Julie Wish, Aisley Cheney, Colleen Frank, Helen Peterson, Helen Wong, Felipe Almeida de Pino Ribeiro, Abi Iyer, Michelle Rudman, and Wade Self. All are participating in this program. And I think the program is led by Susie Stark and Joy Snyder, and it's been incredibly successful at getting people along in their career. There's also a T32 Scholars Program that, as I remember, it's Eric McDade and Joy Snyder run this program. And this supports postdoctoral trainees and predoctoral trainees. So this is a fantastic way to support the research during those phases of their career. You can see all the people. I'm going to move on so we have time to finish. Okay, so for me, this is always the most fun part of this meeting because I get to update some of the many scientific advances from the Knight ADRC of the last 12 months. Please don't get mad at me if anything you publish is not on this. I just tried to only pick out a few things to highlight. So here we go. So just a few months ago, an incredibly interesting paper was published by Kellen Peterson and Suzanne Schindler's group. You can see all of these papers I'm going to highlight. You can see all the co-authors, how collaborative this place is when we're doing studies like this. So what they found is that they created mathematically a way to create what's called plasma p-tau217 clocks. So previous to this, other people had used methodologies to use amyloid imaging for example, to form clocks. And what this allows you to do is to get a certain value on whatever test you're doing, and then make a prediction based on that value of when somebody is going to, let's say, convert from normal to impaired. And in this study, what Kellen, Suzanne, and others found is that by just this blood-based biomarker measurement, depending on your age, it could predict roughly when you were going to become impaired. So if you were, for example, if you became positive on the blood test and you were 60 years old, it took about 20 years before impairment occurred. But interestingly, if you were older, let's say 80 when the test was positive, then it took a shorter time to become impaired, probably because people who are older have additional comorbidities in addition to Alzheimer's disease. So really interesting study. More work to come on that, I'm sure. So one of the things, one of our Puletsky Award winners this year, Daniel Western in Carlos Cruchaga's lab, published a really nice study looking at assessing in an unbiased way many proteins in the blood and in the spinal fluid, and tried to see whether different genetic variants in our genome was related to the level of proteins in these biofluids. And what was really interesting is that if, let's say, you found different genetic variants that altered certain proteins in the spinal fluid, or you found them that they were linked to changes in the blood, 70% of those changes in CSF or in blood did not overlap with the genetic change that was seen. Well, 30% did. And what's also interesting is that the CSF changes were more predictive of what was actually going on in regard to pathology and clinical features. So I think it really points out that these two fluids, obviously they're not the same, but even the genetic changes that influence changes are not always the same. So in terms of genetic modifiers of autosomal dominant AD, genome-wide association studies, we know that certain mutations in genes like presenil-1, presenilin-2, and APP cause autosomal dominant Alzheimer's disease. But what Dr. Patel and in Cyril Poitier's lab working with Carlos Cruchaga found, they actually identified different genetic variants, 3 new genetic variants that alter risk of when you actually get autosomal dominant Alzheimer's disease clinical manifestations. So I think what this will hopefully uncover is new targets that we can ultimately develop potentially for therapies. So one of the things that has been uncovered by Eric McDade, Randy Bateman, and many investigators, both here and at other institutions, is looking at not just the outcome of trying to treat people, for example, with anti-amyloid antibodies in the dominantly inherited Alzheimer's network, but also looking at markers of changes over time after you get treated. And one of the things that they published in Alzheimer's and Dementia in the last year is that if you look at these curves, what you see is that by amyloid imaging, those that were treated, in this case with gantenerumab, over time had a removal of amyloid that was pretty profound over time. And you can also see that there were parallel changes to this amyloid removal in changes in blood-based biomarkers such as p-tau181 and p-tau217. So I think what this argues is that we'll hopefully, with some of these blood-based biomarkers, be able to follow the course of treatment response, at least in regard to amyloid, and hopefully other treatments in the future will have other markers or maybe some of these same markers. So these are studies that were conducted by James Kennedy and Bo Ansis, Brian Gordon, and many others, looking and comparing what happens in Down syndrome to autosomal dominant Alzheimer's disease. So as you know, 100% of people with Down syndrome develop Alzheimer's neuropathology, as do people with autosomal dominant AD. But what they were looking at is the course of change of damage in the brain similar or different in these two different things that lead to Alzheimer's disease. And what was interesting is that they found that once you start losing brain volume in certain areas in Down syndrome, it's kind of a gradual change over time. But in autosomal dominant Alzheimer's disease, once you start developing changes, it's much more linear and rapid. So perhaps we might be able to uncover some of the reasons for this by further studies of this finding. So one of the goals of the NIGHT ADRC is to, of course, look at not just white people that are highly educated. We want to look at the whole community. So in this study that was done by Arya Ashfaq, Ganesh Babalul, Joy Balsberry, Jessica Mazursky, Krista Mulder, and John Morris, they did an analysis of the literature to try to better understand what are the factors that are important in community engagement, recruitment, and retention of minoritized participants. And the main highlights of the study were that it examined strategies for engaging, recruiting, and retaining historically underrepresented ethno-racial groups in ADRD, and also successful engagement strategies that encompass building trust through long-term community partner involvement, utilizing culturally tailored educational materials, and forming partnerships with community-based priorities. And I think organizations, and I think this is something that the group here has really learned over time, and I think it will hopefully contribute to research in this area around the whole field. Okay, so I'm back to a little bit more basic science. As you know, anti-amyloid antibodies are approved for therapy when given peripherally. What was explored in this study that was, first author was Yun Chen, a postdoctoral fellow now in my lab, but he was a joint PhD student with Marco Colonna and I at the time that this work was done, is they developed a way to deliver a domain of anti-A-beta antibodies via gene therapy into cells in the brain. So one-time delivery, astrocytes in this case expressed this binding domain, and then they put an intracellular domain into these cells that had a less inflammatory cascade result when amyloid was removed. And they were able to achieve a very strong removal of brains that already had a lot of amyloid with this approach. And also some of the other findings were that the inflammatory response was mitigated compared to, let's say, standard anti-amyloid antibodies. So there's a really interesting new approach to think about in the future. So one of the questions that Celeste Karch's lab has been interested in, and the first author of this paper is Farzana Mirfakhar, who's also, again, one of our Pilecki winners this year, was trying to better understand the process of autophagy, a way that cells degrade things, including misfolded proteins like tau. And what they found in this very nice paper is that there are mutated forms of tau that cause diseases like frontotemporal dementia. And if they put that mutated form of tau versus normal tau, and they studied its metabolism, they found that the mutated tau kind of gums up the autophagy system, and you can see it accumulating on the edges of lysosomes instead of inside the lysosome. And I think by understanding more about what causes autophagy dysfunction as well as causing better autophagy, this is something that's being explored by several groups here to try to develop new treatments for the disease. So one of the things that my lab, Eric Music's lab, and Brendan Lucy's lab, Yoel Ju's lab have been studying is the impact of sleep and or the circadian rhythm on different AD-RD pathologies. And in this paper, what Eric's lab did was to use a dual orexin receptor antagonist called lemborexant, which is an FDA-approved drug for sleep. And they administered this to mice that develop amyloid at different doses. And they found if you started right at the beginning of amyloid deposition, you could really markedly suppress future amyloid deposition. And this is helpful because this is actually a known used FDA-approved drug. And so one of the things that this kind of study supports is a study that Brendan Lucy's been doing the last 3 years here at WashU, which is giving people with preclinical AD a similar drug to try to see if it suppresses further amyloid growth. And so hopefully other trials like this will move into AD in different ways in the future. And the last thing I'll show is just a paper that's from my lab that's in press, where we've been looking at the adaptive immune response, and this was led by Hao Hu and Jason Ulrich in our lab. And what was found was that if you normally T cells appear to be getting into the brain in the setting of tauopathy and leading to damage in the brain. And what Howe found is that there are antigen-presenting cells that allow T cells to get activated called dendritic cells, CDC1 cells. What's really cool is when you remove these cells, you can see all the damage in the brain of these ant tau mice. When you remove these cells, they get very little damage in the brain. And these cells are not even in the central nervous system. They're in lymph nodes, they're in the meninges. So this might suggest if something can be used to target those cells, you wouldn't necessarily need to get the targeting into the brain. Okay, so to sum, the Knight ADRC, as you can see, is thriving. We have incredible clinician scientists, staff, and administrators. We want to thank everybody involved in the Knight ADRC. It wouldn't be what it is without all of you. It's definitely a team effort, and we have a great team. And I think I'm okay to take a few questions if anyone has any. So thanks so much.